Hello, I'm Efşan Çakır, the team leader of Group 26. Today, I'll briefly introduce our project, the Smile Activated Shop Door. Let me start by introducing the team. We divided tasks by strengths. You can see the members. I am Betül, handled software and testing. Ayça focused on system testing. Mehmet worked on hardware setup. Now let's look at the motivation behind the project. The Smile Activated Shop Door was designed in response to the increased need for contactless interactions in the post-pandemic era. Importantly, the system operates offline and does not record any data, ensuring privacy. With this context in mind, let's talk about what specific needs and objectives we aim to address. We are required to design a system that can detect a user's smile in real time and automatically trigger a door mechanism for touchless access in public spaces. Our goal was to develop a safe contactless entry system suitable for public and high traffic areas. The system encourages user engagement while eliminating the need for physical contact, ensuring both safety and convenience. To meet this objective, the system must detect smiles accurately in real time, ensure privacy by offline non-recording processing, operate hands-free for hygiene, be low cost and energy efficient, be scalable and easy to install with minimal hardware changes. Now that we have defined how the system should behave, let's move on to how we structured our design to meet these needs. Our system has three main layers. First one, image processing for facial expression detection. Second one, hardware for servomotor control via PWM. And the last one, control layer for coordination. We used a modular tap-down design for easier development and reliability. Let's now take a closer look at how each part of the system works together in detail. First, the camera captures 640 by 480 images. Then OpenCV processes them using hard cascade classifiers for face and smile detection. After a smile is detected, the Raspberry Pi sends PWM signals to two servo motors, which then open the door panels. Meanwhile, the system gives real-time visual feedback to confirm detection. Thank you for listening.
Hi, I'm Sena Türetken. I will talk about implementation details of our design. Here is the general description of our design. We structured our system using a top-down layered architecture. Image processing layer, hardware actuation layer, control layer, system management layer, and user interface layer. Here at the main components we used. Now let's look at the software architecture of our system. The servo motors are controlled using PMW signals via GPIO pins. The set angle function adjusts motor angles. The open and close function opens and closes the door smoothly by rotating both motors in opposite directions. We use OpenCV and hard cascades for smile detection. After all operations are completed, the program safely stops the camera, resets the motors, and cleans up the GPIO pins. So let's look at our flow chart. This diagram summarizes the flow of our system. It begins with camera activation, continues with face and smile detection, and executes the door control logic and ends with safe shutdown. In testing, the system reliably detects smile under standard lighting. It responds within a second and performs well without internet. The servo motors function smoothly and the system proved to be safe. This slide gives a deeper look into each hardware piece. The Raspberry Pi runs our code. The camera captures visual input, and servo motors control the doors, and the 3D printed doors is our physical output. All components run on low voltage and are safe and compact for real environments. Thank you for listening.
Hello, my name is Gökhan Bilgin. Today I'm going to present you testing part of our project. We divided it to one is software, one is hardware. In software part, we really hard on it because the code not detected very well in the beginning. When you smile, it didn't detect it, when you didn't smile, it detected a smile. We fixed it end of the day. There is a hardware part. In hardware part, there is servo motors. Servo motors only turn 180 degrees, and it's not enough for our door opening or closing because our door is very big. We fix it with gears. We use 3 gear, 2 is big, 1 is little. So there is enough long for our door opening or closing. And then we start testing the door with just servo using, not with code. Just open servo and close it. but we need to change speed and distance. We fixed it. End of the day, we both connected each other, the code and the servo motors, and it worked very well together. Thank you for listening.
Hello, my name is Karataş. In this presentation, I will talk about the cost, real-world use, safety, and compliance aspect of our project, the Smile Activated Shop Door. Our prototype cost is approximately 4,600 Turkish lira. The most expensive items were the Raspberry Pi and 3D printed door, which together accounted for more than half of the total cost. Other components like the camera, servo motors, power supply, and tools were relatively affordable. In mass production, we can significantly reduce the cost by replacing the Raspberry Pi with an ESP32 cam using laser-cut plastic instead of 3D printing and designing a custom PCB. This would lower the cost to around 700 lira per unit. This system can be used in shopping malls, retail stores, schools, museums, and offices as a hands-free and interactive door solution. The system operates as 5 volts, which is electrically safe. We used low-torque servo motors, so the door moves slowly and poses no injury risk. No personal data stored or transmitted, so design is fully GDPR and KVKK compliant. All components are RoHS compatible and environmentally friendly. To summarize, our system is affordable, safe, and privacy compliant. The prototype cost was 4,600 lira, but is scalable down to 700 lira with minor changes. We believe this system is ready for real-world application in public and commercial environments.